Cool. So let's do one more, where this time I'm going to use the second method. So let's imagine I have those two vectors. This one, I'm given A 30 degree and B 60 degrees. Okay, same thing. Let's calculate the second method, the method of not having to use all our angles from the positive x going counterclockwise, like we just did on the previous problem, where we defined the angle of 270. Alright, so I'm going to use the same coordinate system, x and y. I specify my direction with the little arrows, and I would like to express A and B in component divisions, or I can add them up as my vector C. So first I need to define vector A. Now vector A is not being defined with an angle from the positive x going counterclockwise, so I need to identify my right angle triangle. In order to identify your triangle, you know that if you pick the angle given to you 30, your triangle must be around that angle, obviously. So you know your angle is around there. Then you just need to complete it with the right angle, and that's it. So you're going to pick A, decompose as a y first, and then ax. And I always do a little diagram so that I don't forget my signs. If I write it down on my little diagram, I see right away that ay is positive. Up, I make a little note. I see that my ax going left. Up, I put a little note. I expect it to be negative, so I don't forget my signs. And as Anthony suggested, the ay is obviously the adjacent, therefore it should be the cosine, and the ax is the opposite, therefore it should be the sine, with our negative sign. So if A, whoops, let's use 3 and 4 as magnitude, we have negative 3 sine 30. Yeah, don't forget the negative sign. And plus 3 cosine 30. Okay? Let's do B. B, my angle is defined between this line and this line. So definitely I want to decompose my vector B as Bx first and then By. My Bx will be the adjacent, cosine of 60, and my By will be the opposite, therefore sine of 60. My By is going down, therefore I need to remember to put the negative sign. My Bx is also going left, therefore I need not to forget my negative sign. So B will be negative 4, this one is a cosine, and negative 4 sine. Okay, once this is done, then the rest is easy. Vector C is just the sum of those two guys. The sum of those two guys. Bang, done. And then I can use Pythagorean theorem backwards. I'm going to take whatever is here, square it. Take whatever is here, square it. Add them up, take the square root. I got the magnitude. And for the direction, I take this component. I divide it by this component. I take the arc tangent, and I've got my angle. And then at this stage, to figure out which angle I'm dealing with, from my picture, I know that roughly my C vector will be around there. But I didn't do it on scale, so I'm not too sure if my vector is here or if it's here. But I know for sure my x is negative. And this should be reflected right here. I should have a negative sign here. If this term is bigger than this term, then it will be above. If 4 sine 60 is bigger than 3 cosine 30, then it will be under here. So again, depending on the sign that I get on the y and the x, I will know which quadrant my resultant vector will be in. And as I check the negative sign, I will know whether the calculator is going to give me a big angle or a small angle. Then I can either add 90 to the angle given to me by the calculator, or I can take 180 minus that particular angle in case I'm in the second quadrant. Okay? Questions on this? Yes, yes, yes. We can use the first method. So for vector A, what I would do is I would redefine the angle that defines vector A as 90 plus 30. So theta A will be 120. And then I can just put 3 cosine 120, 3 sine 120. Absolutely. Similarly for B, I can just redefine angle 60 in terms of the positive x going counterclockwise. That will give me 180 plus 60, and that's 240. Therefore, the x component of B will be 4, positive 4 cosine 240, and positive 4 sine 240. J. And as you plug cosine 240 in your calculator, you're going to pick up the negative sign, which we had to add manually with the other method.